All right, this is going to be a brand new lesson to all of you. This lesson is about ellipses. And when you're younger, you might have been told that this is an oval. But as we get older and as we get into mathematics, this is an ellipse, which is a conic section. So if you take the cone and instead of going parallel to the base, if it is at an angle, that's the shape that's created, which is that oval, which we're now calling an ellipse. So we're going to do a mathematical definition, and then we're going to work mathematically with an ellipse to be able to graph it and be able to understand the equation that graphs it. So an ellipse is the locus of points. Now, locus is such that, and in this case, that the sum of the distance from any points on the ellipse to the two fixed points remains constant. So, So if you take any point on this ellipse and measure the distance to these two fixed, and when you have more than one, you call it a foci. So focus is one. Two of them, you would call them foci, F-O-C-I. Anyways, take any point and you measure the distance to both of them. They will always add up to the same number, no matter where you're at. That's the definition, the mathematical definition of it. So these fixed points are called the foci. That's the plural name of focus. And if you add those two distances, D1 and D2, and they would change as you pick any point on the ellipse, that what they add up to will always add up to the same amount every time. All right, for an ellipse, we have a center, we have axes that go through the center. So if I look at this ellipse, along the foci, if I draw a horizontal line through that, and because it's wider than it is taller, this is a horizontal ellipse. So the horizontal axis is called the major axis. So the longer axis is the major axis. And the longer axis contains the foci. The minor axis is perpendicular to it and cuts it exactly in half. So it's the shorter axis. And you can have an ellipse that is vertical or horizontal. So the shorter axis. The center is the point where the two axes intersect. The vertices are the endpoints of the major axes. And we actually have co-vertices. Those are the endpoints of the minor axes. So an ellipse has four vertices. These are at the ends right here. And if they're on the major axes, they're called the vertices, and on the minor, we can call them co-vertices, but there's four of them. So there are two types of ellipses we're going to look at. One's called a horizontal ellipse, and the other's called a vertical ellipse. So obviously horizontal is wider, and a vertical is taller. The vertices that you see, which is the major one, when you have an equation, where's our equation? Here. Let's go back down here. We'll do the equation and then come back up here. So the standard form for an ellipse is x subtract h squared. That's for a horizontal. Plus, like a circle, y minus k squared over b is equal to 1. So hk, like your center, like your circle, is your center, and the square root of a squared and the square root of b squared is kind of that's the length of your, or the amount you count, like your radius that you count from the center to create it. So we actually have to double it to figure out what the actual length is. So think of this kind of like the radii of a circle, where we took the square root and we count from the center. That's how many we count: up, down, left, right, and so on. For a a wide ellipse under the x will be the bigger number. For a tall ellipse under the y would have been that one. So where are the vertices, or how far away from the center? So you would add and subtract whatever a is to find the vertices, just like you would add or subtract b from this equation to find the ends points of the co-vertices. The length of the major axes, you double A, and for the minor, you would double B. And then the foci, you'd have to add or subtract C from the center. Now, what is C? So you're going to learn that C is the square root of A squared minus B squared. So when we get an equation, we're first going to understand A, B, and C to be able to understand where we're going, NHK for the center, and then we're going to analyze it from there. So what is a vertical ellipse going to look like differently? Well, the A and B will be switched around. So B is the shorter axis, so it'll be under the X, the smaller number. And then under the Y will be the bigger number. That's A now, so it's been switched. And it's still equal to 1. Notice for a circle, it could be equal to 1, but it doesn't have to be equal to 1. But for ellipse, it will always be equal to 1. If it's not equal to 1, we would divide. And you're going to see fractions. And if you don't see a fraction, that means the denominator is 1. But that's not normal. Usually, there'll be a number that you do see that we need to work with. All right, enough of the introduction to an ellipse. No longer an oval. Now, let's work with it and learn about it. So turn the page. So first, we're going to learn how to graph it. So in number 1, the first thing I'm going to write down is what's the center for this ellipse. And it's in standard form. So from the numerator, there's nothing adding or subtracting inside, so the center of this ellipse is 0, 0. I need to know what A equals. It's the square root of the bigger denominator, so the square root of 64, which is 8, which means this is a horizontal ellipse. It's going to be wider. B is the square root of 25. So we're going to count up and down 5. So here, sorry, the center is 0, 0. And then when we find the C, it's the square root of A squared minus B squared. So if I look at the denominator is already A squared subtract, or A squared and B squared. So in other words, just subtract the denominator. So 64 take away 25. That's the square root of 39. And we're going to estimate what that is. Now, the square root of 36 is 3. And the square root of 49, or square root of, what? Square root of 36 is 6. And the square root of 49 is 7. But it's a little bit closer to 3. So if we're going to estimate it, it's 3 and a little bit. Without a calculator, that's fine. It's a little, 3 and a little bit. 6 and a little bit. So it's a little bit bigger than 6. So we'll count 6 and a little bit, and we'll estimate where they are. When we put the foci on here, we're going to put a little X there instead of a point, just to identify the foci of it. All right, the vertices. So to find the vertices, I'm going to add or subtract 8 to this. So if I add or subtract 8, if I add 8, there you go, and it's 0, the y-coordinate stays the same, or subtract that number, so it's negative 8. So positive 8, 0, and negative 8, 0. I'll find what those are. It's a 10 by 10. Now, for the co-vertices, the number is 5. So I'm going to add or subtract 5, and that's going to be to the y value only. So I'm going to go up 5 and down 5. Excellent. And you have your center right here. So already we could connect and make our oval. There's our oval, or ellipse, right, that we're going to call it now. The foci is you would take the center and you would add or subtract root 39. So that would be root 39 and 0 and negative root 39 and 0. And we said we're going to go 6 and a little bit. So 1, 2, 3, 4, 5, 6, and a little bit. We're going to use an X to tell me where the foci is. We're going to do the left two. 1, 2, 3, 4, 5, 6, and a little bit. And those are your foci. So if I take any point on this ellipse and measure the distance to both foci from that point, when I add up those distances, if I took another point, it would be the same thing. The sum of those distances will be exactly the same always. Hey, you did your first ellipse ever. I'm really proud of you. Let's try it again. The first time you do something, if it's not a little uncomfortable, then did you really learn something new? Because anytime you learn something new, it breaks a bit inside you until you learn and build yourself back up again. So there has to be something that feels like a little broken, because when you break it, it then builds up, and now you've actually learned it after you break down just a little bit. So 2, let's try it again. First thing I look at, it's in standard form. So in standard form, the center comes from the numerators. That's going to be, you change the sign, it's positive 5 and negative 2. Now, I'm going to find these out. What's A equal? The square root of 9. What is B equal? The square root of 36. And then C is the square root of, and you subtract them, the bigger number first. Notice the larger number is under Y, so this is going to be a vertical ellipse. So 36 take away 9, that's 27. So this is the square root of 36, take away 9, there it is 27. That's what I meant to say. And then if I was going to estimate the square root of 27, the square root of 25 is 5. So it's just 5 and a little bit. So we got a little bit more than 5. Now we're going to do some work here. So the center is at 5, negative 2. So I'm going to find that. So we'll count 1, 2, 3, 4, 5, negative 2. So I found my center. The vertices. So to find the major vertices compared to the minor, because we talked about that too, major is the longer one. So for the longer one, I'm going to add or subtract 6, but it's to the y coordinate. So the x will stay the same. If I add 6, and I'm going to do the same thing, and I'm going to subtract 6. So we have 5 and 4, and 5 and negative 8. So there's 5, 4, and negative 8. So that's the major axis, because it's going to be the longer one. The co-vertices are going to be with the x's. So it's 3. So if I add 3, I get 8 and negative 2. If I subtract 3, I get 2 and negative 2. So I'm going to find 8 and negative 2. And I'm going to find 2 and negative 2. And now I'm going to draw my ellipse. Now the foci, I'm going to use root 27. Now the foci is along the y, the longer. So I'm just going to take the center, which is 5, and I'm going to write this efficiently for you. So 5, negative 2, but to negative 2 for the foci, you're going to add and subtract root 27. And yes, you could simplify it. I don't want you to. It's not what the task is. Leave it at root 27. And this is 2 points, but you add and subtract root 27 to negative 2 because it's vertical. We would do the same work to 5 if this was horizontal. So how are we going to label it on our graph? From the center, we're going to count up 5 in a little bit. And we're going to count down 5 in a little bit. So it's right before the, it is right before the vertice, the major vertex is the foci. Number 3, the center. So the center is at negative 7 and 0. So I'll find that. There's the center. Is this going to be a vertical or horizontal ellipse? Well, where's the larger denominator? Under the x or y? And so because it's under the y, do you know how I did A and B here? I flipped it around. This technically is B, and this technically is A, because the smaller number is always B, and the bigger number is always A. I will make that correction right here. So for this, the square root of 81, that's A, and the square root of 4, that's 2. and then the square root, and you subtract them. So that would be the square root of 77. That's going to be the foci. So if I was going to approximate that, what is that close to? So the square root of 81 is 9. So it's close to that. So like 8, 7, 8, 8, 8. That's a good estimate. So it's almost 9 is where I would put it. So it's 8, 8. Okay. Where are the vertices? Can you find them? So for the major, we're going to use 9, and it's going to be added and subtracted to the y coordinate, because it's underneath the y. For the co-vertices, or the minor vertices, we're going to add and subtract 2, but to the x's. Now we're going to put those on our graph too. We're going to count up 9 and down 9. And then to the right 2. And to the left 2. And now you have your ellipse. And the foci is always along the major axis, the longer one. So to that, 8.8. So if I count from the center and go up and down that, it's almost there, right? It's not quite 9, so it's right very close. I'll put a little X there, very close to the vertex there. Now how do I write that? So again, we're going to go -7. It's the y value. So 0 I don't need, but I added and subtracted root 77. All right, turn the page. Let's try it again. So the center here is at 2, 6. The square root of 16 and the square root of 6. Now the square root of 6 is irrational, so we're just going to estimate it. So it's a little bit bigger than 2, so like 2.2, 2.3, something like that. So we'll estimate that one. C, to find the foci, you subtract. So 16 take away 6, that's the square root of 10. And the square root of 10 is very close to the square root of 9. So it's a little bigger than 3, it's like 3.1, 3.2. So now for the vertices. So the center is at 2, 6, so I'll put that on here. There's 2, 6. For the vertices, because it's horizontal, I'm going to add and subtract to the x coordinate. So that number is 4. So add 4, and then I'm going to subtract 4. So 6, 6, and -2, 6. So there's your horizontal axis length right there, your major vertices. And then to the other one, it's the y coordinate. And so we're just going to add and subtract root 6. Those are the exact answers. To the minor vertices, to put them on my graph, is I'm going to go up 2 and a little bit and down 2 and a little bit. So I'm going to go up 1, 2 and a little bit, and then go down 1, 2 and a little bit. So I can estimate it on my graph. You can see this is going to be a horizontal ellipse. So I'm going to connect all the vertices together and make my ellipse like an eyeball looking right at you. The foci, root 10 is 3.1, and that's along the horizontal. So to the horizontal, I'm going to add and subtract root 10. And then to estimate, it's 3 and a little bit when I estimate it. So it's like 1, 2, 3, and then also to the left, 1, 2, 3. All right, number 5. Step 1, can you find the center? Next, which one has the larger denominator? So A is going to go with root 75, and I'm just going to estimate it. So root 81, root 64, so it's between 8 and 9. It's pretty close to in the middle between them. So like 8.5, 8.6, just estimating it. B is the square root of 20, and again, I can only estimate that, and that's kind of in the middle too, like 4.5, 4.6. And then C is the square root where you subtract them. So 75 take away 20, so that's 55. And the square root of 55, again, is kind of in the middle between 49 and 64. That means the square root of 49, 7. Square root of 64, 8. So in between 7 and 8, it's pretty close to 7.5 again. And then I'm going to put those on the graph. So let's start with the center, which is at 0, -4. And then I'm going to count. So again, this is a horizontal ellipse, so I'm going to count 8.6. So if I do that, the exact answer is positive and negative root 75 and -4. So that's a 8.5 to the right, and then 8.5 to the left. So those are my ends of my major axes. My or my minor axes, or minor vertices, I take -4, and I'm going to add and subtract root 20. So from the center, I'm going to go up 4.5, and I'm going to go down 4.5. So now I have all my vertices, so I'm going to connect the vertices together and make my ellipse. My foci are along the horizontal. So I take the horizontal and I add and subtract root 55. So it's root 55 added and subtracted to the horizontal, which is 0 and -4. So that's graphing ellipses. Now what we're going to practice is not graphing, but what happens when the equation is not in standard form to graph and to get the center and the axes and vertice information, the foci, and so on. Can you take this and rewrite it so that you can get the information that you need? So in this equation, the first thing I notice is that it's not equal to 1. So I'm going to divide 225, all the terms by that. So when I divide by 225, 25 does go into 225 evenly. That's 9 quarters, or 9 times. 9 goes into 225. Well, we just did it, right? Because the answer is 9. So this side actually be 25. And it's equal to 1. When it's equal to 1, you put it in standard form. And the numerator have to be perfect squares. So we don't have a linear term, so x squared and y squared are perfect squares. Number 7. Oh, anything? No, I don't need to find any information. Just write it in standard form. Number 7. I'm going to rearrange this equation. So I'm going to put the x's together. So we're going to add 24x. The y squared can be beside it, and then we have 28. Before I divide by whatever this number is, 28, to make it equal to 1, I need to complete the square first, and then whatever the number is we end up with on the right side, then I divide to make it equal to 1. So I want to complete the square here. The only way to complete the square here is actually to factor out what's in front of the x squared. So to complete the square, the quadratic term needs to have a 1, not a 4. So what we're going to do is I'm going to factor that 4 in front so that it's now 1 inside the parentheses. And 24 divided by 4 is 6. I don't need to do anything to y squared or 28 yet. So I just factored the 4 out in front. Why? Because I wanted x squared to have a 1 in front so I can complete the square. If that quadratic term doesn't have a 1 in front of the x squared, I can't complete the square. Now the 4 is still going to come in when I figure out what number I should add to the right side. But right now, I don't need to worry about the 4, just inside. And how do I complete the square inside? I take the 6, divide by 2, that's 3, and then square it. So can you see where the 9 comes from? But here is the challenge, not a big challenge. The number I add to the right side is not 9. Why not? Because of this 4. So 4 times 9, if I distribute it and expanded, that number really isn't 9, but is 36. So that's the number I'm going to add to the right side. And notice why it's 36. Now it's going to get a lot easier. So some good algebra work there. We're going to factor. So that's x plus 3 squared, and then y squared. And then 28 and 36 is 64. And then the last step, now we divide by 64 to make it equal to 1. So I'm going to divide everything by 64 to make it equal to 1, and then simplify what you can. So 4 goes into 64 16 times. And we have that equation of our ellipse. Number 8. Let's try again. So step 1. Can I put the x's and y's together? So I have a 9x squared and a negative 36x. I have a y squared and a 10y. And then the constant I'm going to subtract to the other side. That's negative 52. Now, I need to now notice, can I complete the square for each one? Now for the y, I can, the way it looks, because the y squared has a coefficient of 1. So I see 1y squared, it's ready. But not this one because of the 9. So in order to complete the square, I need to factor the 9 out. So when I factor it out only for the x's, 9 goes into 36 4 times. Now we're ready to complete the square. So inside the parentheses, I need to divide by 2 and square it. So that number is 4. So negative 4 divided by 2 and square it. To the y, I'm going to do the same thing. Divide by 2. So 10 divided by 2 is 5, and square it is 25. Now, what number do I need to add to the other side to make sure it stays the same equation? So even though I added 4, is it really 4 if I distribute it? And the answer is no. I have to go 9 times 4, and that number is actually 36. Then, when I look here on the right, here for the y's, there is no number in front of the y. So the number I got is the number I need on the other side, which is 25. I'm now going to combine these together. So this is 61 and negative 52, so that's 9. And then divide everything by 9 to make it equal to 1. I'll do that next. We are going to do that. So we're going to factor. So this is x subtract 2 squared. We're going to factor. That's y plus 5 squared is equal to 9. And then we're going to divide by 9, everything. And then we'll have our answer. So simplify it. 9 divided by 9 is x minus 2 squared. The denominator you don't see is 1. Then it's y plus 5 squared divided by 9, and then it's equal to 1. So can you take an equation and write it in standard form by combining the x's and y's together, factor out the quadratic coefficient if I need to, complete the square, make sure you know what you're adding to the right side to keep them the same, and divide and factor. So I know there's some good algebra here to make it work, but I know you can do it. All right, number 9. So step 1, the x's. Step and the y's, put them together. 224 can stay on the right side. Next step, factor out a 9 for x. Now I'm going to do this right away. Divide it by 2 and square it. So that number is 4. I'm going to factor out a 4, and I get 8. Again, divide by 2 and square it, and you get 16. Then, what numbers do I need to add to the right side? So 9 times 4 is 36. 4 times 16 is 64. So if I put that together, that's 324. I'm going to factor. So I have x plus 2 squared, 4. I have y minus 4 squared, factoring, is equal to 324. And then the last step is to divide everything by 324. So 9 goes into 324. Believe it or not, you could use your calculator if you want. Divide it, that's 36. That's x plus 2 squared over 36. 4 goes into 324. That number is 81. Again, it's okay if you want to use your calculator. And then, of course, the right side is equal to 1. That's how you know it's in standard form at the end. Number 10. So we have x squared plus 10x. We have 4y squared and negative 16y. For the x, I don't need to factor, so the number to complete the square is 25. For the y, I'm going to put parentheses around it just so you can see it separately. I'm going to factor out the 4, so you have y squared minus 4y. Now, just inside the parentheses, divide by 2 and square, that number's 4 to complete the square. Now, what numbers will I add to the right side? So I need a 25 on the right side, and then 4 times 4, I need a 16. Now, add those up, 155, 25, and 16. Then you're going to factor. So this is x plus 5 squared. This is y minus 2 squared. And that's equal to 196. And then the last step is to divide everything by 196. So I have x plus 5 squared over 196 plus 4 does go into 196 evenly. If it was 200, it would be 50. So 1 less than that would be 49. And that's equal to 1. All right, one more. We're not going to do the eccentricity at all. So you can go, no way, Jose. Done. 11. I'm not doing that part. So for number 11, bring the x's together. Add 150x. Bring the y's together. Subtract 16y. And then leave 159 over there. Now, I'm going to factor out the 25. So 25 goes into 150 how many times? How many quarters is that? And that's 6. And then divide by 2 and square, that's 9. We're going to do the same thing here. Factor out a 4. That leaves me with 4y. Then for the 4, divide by 2 and square, and you get 4. You're being algebra machines, I'm telling you. And then what number gets added to the other side? So 25 times 9. That is 20, that is 9 quarters. It's 225. And then 4 times 4 is 16. So that's the number you're going to add up on the right side. So 159, 225, and 16. So if you add that up, it's actually exactly 400. Next, I'm going to factor. And then as I factor, I'm also going to divide eventually. That's x plus 3 squared. That's 4. That's going to be y minus 2 squared. And then 400. And then divide by 400, and that will give you your answer. So how many quarters are in $4? That's 16. So x plus 3 squared over 16. Here, divide by 4. So 4 goes into 400. How many times? That's 100. And then, of course, 400 divided by 400 is 1. All right. So again, we're not doing the last questions, which is fine if you want to like Google it or something, but this is where we're going to end with today. We had a good lesson today. It's brand new today. It's frustrating today. The algebra was challenging, but not impossible. You worked with me. You didn't give up. I am really proud of you. So Mr. G Math over and out, and until next time.